Welcome back, students. Let us see the last theoretical video of chapter number 12, video number 49. Means only one video required to complete half century. Okay, during lockdown, half century is too much. Okay, in this video, we will see the de Broglie's explanation on Bohr's second postulate. Right? What was Bohr's second postulate? There was a puzzling postulate. Why this corollary D? Okay? So, let us see what was Bohr's postulate first. So, in that Bohr's postulate, it was about stable orbit, and there was a condition of stable orbit, which was the condition that orbital angular momentum L is nothing but mvr is equal to, what is m? Mass of electron, v velocity of electron, and r is radius of orbit of electron, is integral multiple of n, integral multiple of h upon 2 pi. Why only h upon 2 pi? Why not another? Okay, so for that, Bohr's second hypothesis, de Broglie gave some explanation. Practically as well as theoretically, it was proved that whatever the Bohr has taken, that condition for second postulate, which is true, means de Broglie's explanation give proof of that Bohr's atomic model. Okay, and because of that, Bohr atomic model is considered as the most successful atomic model. Okay, so what is de Broglie explanation? How it was? De Broglie gave explanation after the completion of experiment of Davison and Germer. Again, the topic is there on chapter number 11, that we will see later on. Okay, in that explanation, the particle means here moving particle was electron, and in that experiment, that electron is taken having a wave nature. Same thing de Broglie explained. What it explained? So according to that, de Broglie, after experiment of Davison and Germer, electron is taken as a wave. Means in our case, in case of nucleus and electron, we can say that electrons are revolving around the nucleus in a wave nature. Clear? That view we have seen in 11th standard also. That reflection of waves also we have taken. Okay, so it will be very easy to understand you. Right? On the basis of this assumption, electron as a wave, if you want to draw the figure of revolution of electron around the nucleus in the form of wave, so it will be like this. Say, so this is nucleus. What is nucleus? I gave homework twice. Define nucleus. The center part of an atom where the entire mass is concentrated, as well as it consists of all the positive charges that center of an atom is known as nucleus. And we know that electrons are revolving around the nucleus in a circular orbit. Got it? So, what is de Broglie's explanation? Electrons are revolving around the nucleus in a circular path in the form of wave. So, let us say that electrons are moving around the nucleus in the form of wave. It is like this. Now, there is reflection of wave. So, after that, you will have the stationary pattern. What is stationary pattern? That you know that node point and antinode points are coincide with each other and it form a stationary pattern. Okay, so in that stationary pattern, node and antinode points, they coincide with each other. The wave lose the property of propagation. These things we have seen in 11th standard, and that only thing you have to take. So, electrons as a wave are moving around the nucleus having radius r, and they are moving with velocity v. Okay? So, what the distance it travels? It travels the distance which is equivalent to the circumference of the orbit. Okay? Equations are there on page number 431. That is distance travel. That is 2 pi r is nothing but n lambda. What is n lambda? N lambda. Lambda is nothing but wavelength. So what is wavelength? So this is wavelength. That is lambda. How much wave patterns are produced, that we don't know. Because of that we have taken the integer number n, where n is equal to 1, 2, 3 and so on. See this properly, huh? From this, there is a proof of Bohr's second postulate. So, here it is a different thing. Bohr postulate, it is a different thing. Why he took n h upon 2 pi, that we have to obtain. We have to learn because it was already obtained by de Broglie. Okay? So, 2 pi r is equal to n lambda. Now, we know what we know. What is lambda? But we know that lambda is nothing but de Broglie wavelength. And de Broglie wavelength, lambda is given by h upon p. So here, instead of lambda, it is h upon p. What is h? Planck's constant. And what is p? Momentum of electron. Okay? So, p is equal to, we know that mv. When you will take this p is equal to mv, if the speed of electron, means velocity of electron, must be very less than velocity of light in vacuum. So in that condition only you can take p is equal to mv. When you are taking, if velocity of electron must be very less than velocity of light. in vacuum. So it is N as it is, H as it is, P means 2 pi. So here, what was that? That is 2 pi R. Okay? Think of this. Electron as a wave revolving around the nucleus in a circular path. After one complete rotation, it travels a distance equivalent to the circumference of that circular path n lambda, let us say. Think of that for a few seconds. Okay, few seconds finished. What is wrong? What I wrote wrong? Yes, equation of P. P is nothing but mv. But I wrote here 2 pi, so you have to take mv on this side. That is mvr. Oh, sir, it is like this. Yes, obviously. From de Broglie, there is a proof of Bohr's second postulate. Okay, and because of that, Bohr's atomic model is considered as the most successful atomic model, and we are accepting this. Okay, so MVR is equal to NH as it is upon 2 pi downside, that is 2 pi. So this Bohr explanation gives the proof to that, strong proof to that Bohr's second postulate. And you can say that orbital angular momentum is n. N is varying, that is 1, 2, 3, 4. Means orbital angular momentum having discrete values. Discrete means different values. If electrons are revolving in first orbit, then you will take n is equal to 1. So orbital angular momentum will change. If electron is moving in second orbit, then put 2 to cancel. Again, orbital angular momentum change. So this orbital angular momentum are changes continuously if the orbits are changes. And if orbital angular momentum changes, the energy of electrons are also changes. So this change in orbital angular momentum as well as energy, it gives the quantization of angular momentum as well as energy. Means you will have the discrete values of the different values of orbital angular momentum as well as energy. And this quantization is due to that integral multiple n. Okay, what is n? Number of orbit in which electrons are revolving around the nucleus. Okay, so this was about de Broglie's explanation on Bohr's second postulate. Okay, let us see for a few seconds, and then after we will see the limitation of Bohr's atomic model. Just now we told that it is the most successful model. It is acceptable, which we have accepted, but there are few limitations of Bohr's atomic model that we will see after few seconds. Have a look. Okay? Good. Now, let us see that Bohr's atomic model exam, this question was most popular. Means, write the limitations of Bohr's atomic model. So, it is very nice question. Individually, it can be asked as a 2 mark. Okay, let us see. Limitations of Bohr's atomic model. Okay, let us see. First limitation is odd combination. So I am writing the keyword only. Odd combination. Odd combination means what? Here, while we are obtaining the equation of R as well as energy as well as that Rydberg's formula, what we have done, plus, minus, take common, divide by, multiplication, right? So that is a classical physics, means in which you will do that mathematical steps, you will take that mathematical operations, and whatever we are going to study, that is atoms, nucleus, electrons, it is known as quantum physics. So there is an odd combination of that quantum physics with classical physics. Okay? Second, what is second? Bohr's atomic model is not giving information about number of electrons in orbit. Means in first orbit there are 2 electrons, in second orbit there are, in chemistry it is there, 8 electrons. So the distribution of electrons in that particular stable orbit is not explained. It is not able to explain by that Bohr's atomic model. So first, odd combination of classical physics with quantum physics. Second, Bohr's atomic model do not have any information about distribution of electrons in that orbits. Second. Third, what is third? From that line spectrum, we will have the information about frequency. Frequency of spectral lines are known. Means in that last video we have obtained that Rydberg's formula. In that Rydberg's formula there was an equation, that is, what was that equation? H nu I f is equal to, what was that? Is equal to m e raised to 4 8 epsilon 0 square h square 1 upon n f square minus 1 upon n I square. So from this equation you will get the frequency of the spectral lines. But what about the intensity? So that intensity of that spectral line is not explained with the help of Bohr's atomic model. Means there is a limitation of Bohr's atomic model which is not able to explain the intensity of that spectral lines of that line spectrums. Fourth one. What is that fourth one? Orbits. Means electrons are revolving around the nucleus in a circular orbit. Circular orbit? Really? Why? So, these things were not explained with the help of Bohr's atomic model. Means orbits are circular. Really circular? It may be elliptical, right? So, this circular information about this circular orbit is not explained by Bohr's atomic model. Later on, it is considered as the orbit must be or may be elliptical also. But then after it is considered that equations are true for elliptical orbits also. Okay, so these are about the limitations of Bohr's atomic model. Okay, let us see in detail by using these keywords. Okay, first, there is odd combination of classical physics with quantum physics. Means you have to write, you must have to write during the calculation of equation of radius as well as energy. There was a use of classical physics. In quantum physics, it is odd combination. Second, how many number of electrons are orbiting in that particular orbit? Means Bohr atomic model is failed to give information about distribution of electrons in orbit. Third one, right? With the help of Bohr atomic model, with the help of that equations, right, you can have the idea about the frequency of that spectral lines. But Bohr atomic model is failed to give the information about intensity of that light. Means intensity of that spectral lines are not explained with the help of Bohr's atomic model. And last one, electrons are orbiting around the nucleus in circular path. That circular path is not confirmed by that Bohr's atomic model. It may be elliptical. Okay, so these are the limitations of Bohr's atomic model, and happily this is the last theoretical topic of this chapter. After that, by using two videos, we will complete the exercise examples. Till then, enjoy